Welcome back to another video. This video is on the super function. So the super keyword with the initialization method allows or provides access to attributes and methods present in the base or parent class when you are doing inheritance. So it's necessary for complex class hierarchies that use multiple class inheritance. Let's have a look at this in PyCharm. We are in PyCharm, and to begin with, let's create a class for all cars. We will now initialize the class. And because this class represents all cars, we will have things that all cars has. So all cars have a name of the make and the model, and whether the car has a spare tyre, and what the gearbox is, whether that's automatic or manual. So let's include these as the parameters and the attributes. Let's create the attribute self.make equals make and so on. So these are the attributes all cars will have. They will all have a name of the make and model, whether there is a spare tyre in the car, and what the gearbox is, whether it's automatic or manual. So these are all of the properties that every car has. So I'm including these attributes in the class all cars. Now let's create another class for the type of car, and the type of car will be a family car for this class. And as it's a family car, I want it to consist of the things a family car will most likely have. So let's just pretend this certain family car has the option to have a built-in child seat. It comes with many cup holders. It has additional features as well, such as a TV or the option to have a TV and other entertainment facilities. So now we have created the attributes of Family Car 2. So Family Car 2 will have a child seat, cup holders, and it will have some additional features as well. Family feature _1 and family feature _2. However, we still want to specify the make and model of the car and whether it has a spare tyre and if it's a manual or automatic gearbox. And these are the attributes of the all cars class, the one we just created above. And so if you've watched the previous video on class inheritance, and so as we have done in the previous video, rather than duplicating the same code as the class all car, we can reuse the code that's already been created in the all cars class by calling its initialization method, as that is best practice anyway, not having to duplicate code everywhere and reuse what's already there. But this time we will use something called the super function with the initialize method. So for a simple inheritance design, we can hard code the base class and use the name of the class all cars, and this will execute or run our all cars initialization method. However, when you have many more classes and multiple layers of inheritance, it's better to use something called the super function with the initialization method. The difference is, in the previous video, we hard coded the parent class to call upon the initialization method, but in this video, we will use the super function. So first, let's reference the parent class in the parentheses. And so now this class is a child class that will inherit the attributes and methods of the parent class. So next, let's copy the parameters from the parent class to the child class. So next, we will call upon the super function and we will add the parent class parameters in the initialization method within the parentheses of the child class. So that's it, we have inherited these attributes. You can also inherit methods, by the way, if you watch my previous video on inheritance. That's got some good examples on there. So these are inherited now. So now what we will do is create an object instance called car _1, and it will be part of the family car class. So it will be part of this class here. So it's a Ford Cougar, spare tyre included, it's an automatic gearbox, premium child seat included, there's 4 cup holders, there's a TV and a coffee maker in this car. Now let's print all of this to the screen, and I'm using formatted strings to format the string a little bit better. To format the string itself, so one thing I've noticed, I've missed a Y, and let's carry on, and let's finish off the print statement. Now let's run the file to make sure it runs. Let me remove the I from specification and run it again. So the specification for this car is Ford Cougar, spare tyre included, automatic, premium child seat, 4 cup holders, TV and coffee maker. So what we see here is the attributes from the parent class, these ones here, which are covered make, model, spare tyre and gearbox. And then we have the attributes of the child class as well, the premium child seat, 4 cup holders, TV and coffee maker. So what the difference here is than the previous video. In the previous video, the initialize method for the parent class was hard coded. The parent class was hard coded with all cars. So this is the parent class, and if we scroll down, we have a child class here, class all cars, And then we are calling the initialization method within all cars, the parent class, so it's hard coded. Now the super function is based on what the class is inheriting from, so it's not hard coded. So it's calling the initialization method with the parameters based on the parent class, which is all cars. So now this is basically saying call the initialization method of the direct parent class. And because the family car is inheriting from all cars, it's going to call upon the all cars constructor function. So the super function is based on what the class is inheriting from, rather than it being hard coded. Now this means if we introduce new classes and inherit from another class instead, the super function will call upon the new class constructor automatically, as it's no longer hard coded, and this automatically maintains that hierarchy of inheritance inside of our code without having to manually change it. So super is the way to go rather than hard coding it, because with a single inheritance it's not a big deal, it's easy and quick enough to change, but with many classes and multiple inheritance, you would benefit from super for its dynamic nature.